Planck had proposed that the oscillator energy En is directly proportional to n, a positive integer. We assume that this also holds for the energy of the electron in the hydrogen atom. In that case, the angular momentum would be proportional to 1 upon n root n, 1 upon root n and n. Okay. Okay. Now, first of all, let us look at what exactly do they mean by the oscillator energy. Okay. See, we all know Planck to put a theory of quantum physics, right? So he says that the energy is always exchanged in discrete packets, and each packet of energy is called a quantum. Is it clear? I hope you remember this because we have studied this in photoelectric effect, right? Now, if you take that particular oscillator, okay, we usually have oscillator of the kind spring mass system in our heads when you look at the oscillator, the M and K. But we can also have a quantum mechanical oscillator where the energy will fluctuate between the kinetic and the potential. Okay. Now this is a mechanical oscillator, and what Planck meant was the atom itself behaves as a tiny oscillator. Okay. Fine. So that En, that's the total energy of the electron oscillator, is directly proportional to n. Okay, that's what he said. Now look, these questions, or this question in particular, is not meant to be solved by the already known formulae for Rn and for Vn. Okay, because these formulae have been derived not assuming that En is directly proportional to n. Okay, and you can see that there Rn is proportional to n squared, and here Vn is proportional to 1 upon n and all that stuff. Okay, so what we have to do is we have to start with this and then arrive at a definitive conclusion regarding angular momentum L. Now you have to also know the formula for angular momentum, the magnitude, that is mvr or mvnr. I hope you understood this part. Angular momentum of the electron, orbital angular momentum in the n stable state, is mvnr. Okay, now look, like the spring mass oscillator has its energy oscillating between the potential energy of the spring and kinetic energy of the block, the oscillator or the electron acting as an oscillator, its energy will also have two components. So En will be equal to Kn plus Pn. Correct? Where K is the kinetic energy and P is the potential energy. Got it? Now come back to the fact that if En is proportional to n, okay, we have to say that Kn is also proportional to n and Pn is also proportional to n. Raise your hands if you have understood this. Kn proportional to n and Pn is also proportional to n. Okay. Acha. Now what is the formula for Kn? Can anybody tell me the formula for Kn? Come on, what is the formula for Kn? Half mvn square, right? Half mvn squared proportional to n. Do you know this, or do you understand this? Yes? Okay. So can I say that Vn is directly proportional to root n? Because mass of electron is not going to change. Half is a constant. So is Vn directly proportional to root n a valid statement to make? Yes. Yes. So is that part clear?
Yes, sir.
Which means if we want to determine the proportionality relationship between angular momentum and n, we should now determine the proportionality relationship between Vn and n and Rn and n. Among them, we have determined the Vn n relationship. So what needs to be determined is that Rn relationship. Okay, Rn relationship with n. Okay. Okay. Now, what is the formula for the potential energy? Okay, what is the formula for the potential energy? Tell me. So 1 upon 4 pi epsilon naught. Okay, Z E squared upon Rn. Is that right? Yes, of course with a negative sign, but let's not worry about that too much. So this is proportional to n, which means Rn is proportional to 1 upon n. Z is constant, E is constant, epsilon naught is constant. Raise your hands if you have also understood that. Okay. So if you now know that Rn varies inversely with n, how about Ln? Ln varies with Vn Rn or Vn into Rn. But Vn is varying directly with root of n and Rn is varying directly with 1 upon n. So Ln must vary with root n upon n, or Ln must vary with 1 upon root n. Option B.